This conference will now be recorded.
Because the thing is it asks for the some sort of access, administrative access, and maybe the open software may contain some other issue that will give a problem towards the real work which you are doing. So that's what I don't want to you set up anything on your real on your office laptop.
But this Databricks account we can use, right?
Database
This
is an
should not.
online thing, so you don't have to worry about that. It's simple, like you like online thing, how you access your Gmail, that sort of stuff it is. We don't need to worry about that. The Databricks community edition, if you're going to use that, it is until and unless it is blocked on your office platform. I'm not sure if they have blocked it or not. If it is blocked, then it will be a problem for you. If it is not blocked, then we don't need to worry about that.
Sure. Okay.
Okay. Fine. So let's get started with the today's agenda. What we are going to discuss today. Let me note it down. All the topics which I'm going to cover as part of today's session. So first of the thing I'm going to discuss about what is Spark introduction and why we are going to use this. Second thing is why Spark. Like we already have a couple of other technology available in the market. So then why we go with the Spark side? So that is the second thing. Then the third point. Third is like we already have a Hadoop in our platform. So why we use Spark? That is our third topic today. And if uh, introduction done, Spark architecture 1.x and 2. Now, if time permits, guys, can you mute yourself? Anyone is on mute, Darshan, please. If anyone has to say that, then unmute yourself and you can interrupt me anytime. If it is not, kindly put yourself on mute. Okay. So these are the 5 things we are going to discuss in today's session. So let's start with a Spark introduction. Okay, what is Spark and why we are going to use it? So anyone is having any idea about Spark, that what is Spark is, can unmute and say something about it. I want to know if someone is having any understanding about it or not. Anyone? Okay, all know.
Hello.
Yeah.
So Spark is like means general purpose in memory or compute engine.
Okay.
I don't.
Good. So
Hello.
first, yeah.
It is used for big data processing.
Okay. Anyone? Okay. So Spark is basically, I can refer it to as it's a very light. It's a very light, fast cluster computing engine. Why I'm saying is it is we don't need extra sort of, like if you're going with the Hadoop, then Hadoop is having n number of things. Like it is having a Hive internally, HBase internally, Flume internally, but Spark doesn't need any of the external libraries on that. It is a very light, fast computer cluster computing engine it is. Okay. Second thing is it solves general purpose distributed problem. What is that? I'll explain you later what is general purpose. But as of now, you understand it is meant to be solved the general issue what we are facing with the Hadoop. That Spark is meant to solve that. The third thing is the Spark is like approx 100 times faster than MapReduce. You might have know ki what the problem we're having in a MapReduce jobs. The MapReduce is like the first thing, it's very lengthy in the sense ki the code which we write is if simple, if I'll say ki I have to write a hello program or simple word count program we have to write. So we need to write approx 30 to 40 lines of code to just simple solve a basic problem. That is the major disadvantage of the MapReduce, and it is not like everybody will understand a MapReduce job, since MapReduce is inherited from the Java side. So it will be a problem for other guy who is having Python knowledge, R knowledge, or might not key all of us having understanding about Java. But Spark gives you flavor in Python, R, SQL, whichever comfortable you are, and as well as Scala. So basically, this Spark is built on Scala API. It is functionally built on Scala, but it gives you flavor of other language as well. Might be a few people having understanding about SQL, so they can go for a SQL. Might people a few people having understanding about they don't know Java, they don't know SQL, they might have understanding about Python. So it gives you flexibility around other language as well. So this is a very this is one of the advantage of the Spark, that it is not stick to one language, it is stick to it is giving you option to do your hands-on to understand it better. It gives you flavor in it will give you a flavor in 4 other languages like Python, R, SQL, and Scala. Wherever you feel comfortable, you can go ahead and you can do that. And as it offers the language, it offers you API of that as well. It's not like it give you the support of key I have to write the code in Python, but on top of that, it will give you a flexibility key you can write your code in Python, as well as it give you the API which you can use in your programming as well. Okay, so it is having the main disadvantage of Hadoop is like the first thing, it deals in a batch data. For if you want to have a real-time streaming data, then you have to be dependent on some of the other aspects which enable you the hands-on on a real-time streaming. But if you talk about the complete core Hadoop system, so complete core Hadoop system will not offer you streaming process. Can anyone tell me ki which which are the component we'll use for if I want to provide the streaming with the Hadoop? Can anyone tell me what
We
extra
can use
library you
Kafka
need to add?
or Flume.
Flume is used for streaming, if I'm not wrong. It's used for scheduling the job.
So Kafka can be used for streaming.
Kafka is not a part of big data.
Storm.
It is a separate thing. Storm, correct. So we need to have extra library called Storm. Then on Storm, we are going to use that. We can integrate with the Hadoop. But one thing, it's very much efficient key, and also in big data side, if you have to query the data, you might have to depend on Hive. Correct.
Yeah, either Hive or Impala.
Either Hive or Impala. But these are the other component of the Hadoop. If I'll say ki you have to have understanding about Hive, Impala, then only you can query your data, right? You have to understanding about MapReduce. Then only we are going to write some logic to process data. For processing, either we are going to write MapReduce job, or through Pig also we can do that processing. But internally, Pig job is also initiate MapReduce job internally, right? So everything in big data deals with a MapReduce. But here in Spark, each and everything internally works on RDD. And the other most powerful advantage of Spark is it is very fast. Now, many of you have a question: how Spark is faster than Hadoop? Can anyone tell me why? What makes Spark faster than Hadoop?
Yes, as it works on memory itself only, and no retry operation. Until unless our memory will get full, so we have option to persist in hard disk too. So that's why the processing is fast.
Right, right,
Hello.
correct. So in Hadoop, yeah,
Yeah, so Spark is run on top of Hadoop, right?
correct. It's run on top of Hadoop, but Hadoop having some disadvantage which Spark is going to recover.
Okay.
Hadoop is basically built, Spark is basically built on top of Hadoop itself, but Hadoop is having some disadvantage, which just now I have discussed. It is having language issue. It won't provide you a flexibility to write your code in all the language, like other language. Only you have to write the job in MapReduce, right? Internally, which is similar to Java, correct?
Yeah,
Second
yeah.
thing, performance wise is it is also not that much optimal, like if I am going to compare with the Spark, correct? Now third aspect is what are the other things? the these are the major point, like and third point is like a streaming process. We cannot do a streaming process when we will deal with Hadoop. We have to depend on external library, which is Storm, to deal with the streaming process, right? So all these things, if all these things combine together, and we build Spark to overcome what are the disadvantages of Hadoop. So we have now built the Spark to have an understanding about it, right? To overcome such a problem. But Spark is also one disadvantage, which itself is not recovered yet. What is that? Anyone can tell me?
What was the question?
It can't run without Hadoop.
That is itself, it's built on top of Hadoop. What is the drawback of Spark? There is a one major drawback which Spark is having.
Yes.
It
Yeah,
does
it
not have its
required.
own storage.
No,
Correct.
no,
We
it
don't
required
have it.
time.
Yeah. Someone is telling other aspect as well.
Yes, I'm saying that it required higher memories than the Hadoop. Means Hadoop system can be like normal systems, but in Spark we need systems which have more RAM. Then only it will
Mhm.
work.
Right. Because all the things we are processing in cache, so definitely we are going to have more memory, because Spark don't have its own storage. So it
Yes.
has to depend on explicitly other component. Either we are dependent on Amazon S3, we are dependent on Hadoop storage, or anywhere. It has to be dependent on other vendor storage. The only thing why we use Spark is to process the data very efficiently. Like if I talk about what a MapReduce job can do, process a data. Suppose if a MapReduce job is taking around 100 minutes to solve a particular problem, with having a cluster size of suppose 100 nodes, Spark can do that thing with 10 nodes and with around 5 to 10 minutes. That is the achievement of Spark. Minimal resource, maximum output, it will give it to you. Am I clear till now? I'm taking a pause for a second. If anyone is having any doubt, you can ask.
Can you explain RDT?
That is a separate topic. I'll cover that one as I showed here. RDD and all these things we are going to cover not today. Everything you want it today, say one session.
So, uh, what is AWS and how is it related to Spark or Hadoop?
See, Amazon Web Services we basically use for the storage purpose. So whatever the file, even we will depend on Azure as well. Like some of the application, if you want to do for the storage, like incoming files, or we have some tables, or they're having their own blob storage and all. So that storage is basically the data will reside there for the processing. For the first time processing, we'll use data from there. We'll do all sort of computation. Then again, we need to store somewhere else. So for reading and writing, we have to depend on some other resource. even though if we have less number of data, like around not in GB or something, Spark can also do in memory. But if you depend on its Spark in memory, then its memory is going to utilize by itself and the performance is going to reduce. So it would be better to read and write, we have to depend on some other resource, and for the processing stuff we should be dependent on Spark. Okay,
Okay.
Aman?
Yeah. So I mean, I mean, we can use while using Spark needs to be installed on top of AWS. I mean, in order to use data sets from
Mm,
AWS.
no. Say AWS is like cloud platform. You have access for the, if you have AWS account, you have access to it, so you can pass its key and you can connect it over with the Spark.
Okay. Okay.
You need not physically install AWS. AWS is a cloud platform. You don't need to install it on your system.
Yeah.
So
Okay. Yeah.
URL
That.
and key is in enough to have established, to have a connection between that, and you can do that.
So with AWS, what sort of language can I use? I mean, if I'm using Spark, then I can use any of the language like Python, R, or SQL, right?
See, language compatibility, we don't have any issue with the language when we are dealing with AWS Azure. So one thing you need to understand here is those stuff is basically used for the storage purpose. We have to store the data over there, and REST processing you can do in whatever language you are comfortable with. There is a no restriction with that. But preferably, I'll suggest you better go with the Scala and Python API. If you are good with Java or Scala, you can go with this Scala. If you are not familiar with Java or Scala, you can go with the Python. Since these two language has a lot of support in terms of API. So most of this IT world, or I can say ki in real time scenario, in industry, we basically use around 50 to 60% of the use case we are trying to solve with the Scala. Rest 30 to 35% problem we are going to solve with Python. And
Okay. Okay.
SQL itself is inside that, so you can use that as well. That's not a problem. And that one more thing, if you're trying to solve some issue in Scala, in between that, if you want to use Spark SQL, that's also flexibility this Spark gives to you. It is not like an entire set of code if you want to do in Python, so you have to stick with the Python. Internally, if you want to use your processing in a SQL, you can do that. There is a mechanism. Later, I'll explain about it. There is, you need to convert your data frame into temporary tables, which is nothing but create or replace temp. We use the functionality to register a data frame as a temporary table. Then that temporary table we are going to use with the Spark SQL. So internally also you can fluctuate. If sometimes you want to do some processing in a Python, you can do with the Python. If you want to do in a Spark SQL, you can, well and good, you can do that. That's not a
Sure.
problem.
Thank you. Okay.
Okay. Am I good till here?
Hi Anubhav, Deepak this side.
Uh,
So I want to ask a question. Just like you said, the Spark is working on the top of the Hadoop. So is it like at the
Yes.
backend, MapReduce is processing the data?
No. See, it is built on top of Hadoop, but the main features like the MapReduce, it's override here. We are not going to use, if we are going to use, if Spark is also use MapReduce, then what the exact problem Hadoop is having, it is not going to solve. So internally, everything in Spark uses RDD. If also you're dealing with data frame or data set, whatever, but the internal architecture or the internal processing happen inside in RDD side.
Okay.
Okay. It's just a bit on top of it so that some of the features it will take and might be, and for the storage sake, it is architecture. So today, let me show you. Let me open something.
Anubhav, one more thing. I think currently in the market there is some tool called Atlan. So some of the companies are using like Netflix, Hindustan Unilever, or Facebook kind of thing. So is it like same like Spark? Because I think I have read that in Atlan also you can connect your Python, R, SQL, or something like that.
I don't have idea about Atlan. I am not in a position to say anything about that.
Okay, okay, no,
If
no
I
problem. Yeah,
have something, I'll get back to you. Okay,
sure, sure. Okay.
fine. So as of now in the market, last December 2019, Spark 3.0 has been released. I'm not sure about this internal architecture about the 3.0 because I need to spend time on that. So before going to start with a Spark 2.0, let's have a clear understanding about what the Spark 1.x offers you. Okay. So like typically my Spark, as you can say, it's depend on this uh, driver and infrastructure. It is basically built on driver and slave architecture. So what exactly a driver does here? The driver has a responsibility to launch an application, and with that application, we are going to initiate our Spark context. I'll talk about all this, each of the terms, what exactly Spark, context, cluster manager, work, task. I'll talk about it. But let me explain about what exactly this is this process. So Spark architecture is basically based on driver worker architecture. So it is having application which initiate my Spark context, and then Spark context has cluster manager. The cluster manager will interact with the worker, and it will assign a task to all worker, and worker having executors which is responsible to execute the task. Okay, and inside that executor are physically tasks got executed. Like suppose if I'm submitting a job, then that job is initiated through this application. In Spark 1.x, the first thing we need to create an application. So how we are going to create with that? First, we need to define our Spark configuration. Okay, what are the configuration we are going to define over here? Then with this configuration, we are going to create an Spark context object. And with this Spark context, it initiates our cluster manager. Cluster manager, and then cluster manager interacts with our worker, which is actual responsible to execute our jobs. And in worker, we have executors. Inside that executors, the task is going to execute. Okay. So in 1.x, we need to initiate my Spark context with we are going to pass a parameter as Spark configuration. What this Spark configuration do here? Spark configuration will enable you to in a basic key value configuration which required for initiate the Spark context. So that we are going to supply over here. There are multiple ways through which you can initiate our Spark context object. Like the first is, suppose I want to initiate my configuration object here, so I can do Spark conf like this, or you can give any app names like test or something. So in UI, when you initiate a UI, then this app name is going to show you on the Spark UI section. First, we have initiate the configuration for our Spark system. Then we need to create an Spark context object. With that, we can do I'm going to ref this configuration. I'm going to set it. So this is the way in 1.x you can initiate your Spark context object. So in Spark context, when you initiate your Spark context object, so it is like your application is going to initiate, it is going to execute your job, and then internally it is going to execute all the jobs inside a task. Am I clear till here now?
Yes.
Okay. So let's talk about what driver do, what worker does here, what's executor, and what these is having. What are the responsibility of each of these component of Spark? So let's first talk about what the driver does here. What are the responsibility of the driver? So the first responsibility of the driver is to initiate a Spark context object. Inside our driver the application is going to create, and inside that application we are going to initiate my Spark context. So this is the yeah, Lalit. Lalit, can you mute yourself? Yeah, thank you. Yeah. So what is the responsibility of the driver is here driver resides on the master node. This particular thing resides on the master node, and master node runs the driver program which has a separate JVM. Okay. And the driver program is having responsibility to launch the task. So I'm going to write what are the responsibility of driver is like master node runs driver program. Okay. Then driver program is responsible to launch the task. So the responsibility to launch the task is of driver, and it hosts the Spark context. So these are the responsibility of the driver program we have. And as it keeps monitoring our worker node as well. Okay. So these are the important responsibility of the driver program has. Apart from that, it also has several aspects. It is responsible for the interaction, initiate the Spark environment. It is responsible for the DAG scheduler to schedule a DAG. I'll talk about later what is a DAG. As of now, you just know that DAG is nothing but this is directly a cyclic graph. When we talk about RDD, there I'll explain about how this DAG creation happen and why it is so much important in RDD. And after that, let me write a subset as well. It is responsible for ignore for this typo errors. Then it is responsible for the DAG scheduler to create a DAG scheduler. Then also it's responsible for the task scheduler, which is nothing but it will tell which task is going to execute further. Then some of other aspects like a Spark UI session, through which you can see in Spark UI side, you can see how the cluster health. You are going to check on. So these are the very basic, I can say, the responsibility of the driver program will have. So these are the responsibility which driver program will have. The first thing, it runs inside the our master node. It launches the task. It hosts the Spark context. It will keep track of the worker node key, how the worker node is doing. If any of the worker node is having any issue, then it launches the another task inside a worker node. It is responsible for schedule the job and keep the track of the task which is going to execute, and it will have responsibility for the Spark UI, that it will give you the brief about how the cluster is going on, what are the things cluster health is, and what is there any blockage or something is happening inside cluster. So through UI we can view that as well. So these are the these are the responsibility of the drivers program. So this is this portion. Am I clear till here now? Guys, wake up.
Yes, it is
Okay, for
clear.
today is a boring session, I know, but bear with me for today. So next week onwards we'll have some hands-on so that you will get some understanding about it. But these things, if you're going for any sort of interviews or anywhere, I'm damn sure ki 70 to 80% questions interview guys will ask this question. Okay, what is the difference between Spark 1.x architecture and 2.x? Can you explain in brief about that? Even I have seen a lot of people saying ki, yeah, Spark is based on master slave architecture, so driver is responsible to create the job and then worker is going to execute. That's it. But internally, nowhere you get to know that these are the things the driver program is responsible for it. Okay. So similar wise, the driver program initiate the application. Now what application does here? Can anyone tell me by looking at this graph picture?
Uh,
So
application
the first thing is initiate the Spark context.
Spark context.
Okay. So first thing is like key initiate Spark context here. Okay. Second thing is, if you're creating a Spark context, it internally creates RDD tags. For timing, I'll just give a brief about what DAG is. The DAG will define which RDD is going to run in which order. Like RDD1 is going to execute when, RDD2 is going to execute when. If we have n number of RDDs, then it will give you a plan about which RDD is going to execute at what time. That is nothing but RDD tags. So that also Spark inside application we are going to it create internally RDD DAGs. Okay. Now once this DAG creation happens, it means we are yet to start our job for the execution. Now once you submit a job, like through Spark submit, I'll explain you later what is that. Just understand I have a job which I have submit. So internally when you submit a job, it is going to break in stages. Stages is going to break in a task, and how the number of tasks is breaking, it depends on the number of partition of your data, and then exactly it is going to execute. So once you submit any job, the first internally the job is going to break into stages, then stages is going to break into tasks, multiple tasks, and how the number of tasks is decided, it depends on the partition. How many partition of the data you have, then each partition, each task is going to execute. As here you can see ki as soon as ki Spark context initiate that, executor is having n number of tasks. In one worker node also, in another worker node also, we have suppose n worker. Inside that n worker node, we have n number of tasks, and each task is going to execute. So this is how the parallel processing we are achieving over here in Spark. Ki one job is got splitted inside all the worker node. In all worker node, we have all the data, and it started executing all the data over in each task. Okay. So now, am I clear till here?
Yes. So your means to say like these worker nodes are like stages,
No, no, no,
and the
no,
task.
not stages, not stages. Worker hosts the executors, and inside that executors, we have task. And task is
Mhm.
nothing but it will execute a piece of code. As of now, you can understand a piece of code which is responsible to solve a particular problem. As a context, if a job you have submit, so inside that worker, inside that executor, it form internally stages. Stages is a logical plan. Physically, it is not going to anything happen. It's a logical, but physically, task comes into the picture and it executes the data.
Got it.
Okay.
Anubhav, one
Yeah.
thing, how the job is getting distributed towards the executor. Let's say if we are putting up three jobs, then how does this divide it to the worker like executor, and which executor has to do the which job and all?
That is the responsibility of the driver program. Like which executor is free and which executor have less burden. That driver program will decide. Okay,
Okay.
it is not fixed like every time this worker or this worker or this worker. As already you can see inside this worker, maybe some other jobs are running and this one is a free, then driver program is having keep track, it usually keep track of which worker node is free and available to execute the job. Then it will assign that worker to execute the particular job which you have submitted. And inside that, all the data has been segregated over in each, whatever the data resides here, same data we will have here, same data we will have here as well. Okay, it is not like this, there we have a different data, here we have a different data, here we have a different data. So it is splitted, and it also depends on when you are submitting, so how many partition you are trying to use. Like later I'll discuss about two terminologies, which is coalesce and repartition. Through that also it will decide, but it completely depends on the driver side how exactly it is going to interact with the worker.
And one more thing means whether a driver used to choose only those workers which have the data means in terms of SDFS if I talk.
See, as I said, all whatever the data you have, the same data it is going to replicate here, same here, same here. It is not like different data resides on the different worker nodes. All is having
But
same data.
yeah, that is dependent on
So,
the replication factor, right?
right.
In case means these are the example of three nodes. In case I have four nodes, so out of those three, it will choose only those nodes which have that data, right? If I replication my replication factor is three.
No, 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 no. See, a worker node, you are just confusing here. The worker node is basically, it's a logical thing. The thing here is we have a data. It's not like here also, here we have a different data, here we have a different data, and here we have a different data. We all even fourth also, it depends on how where the data resides and how the driver interacts with which worker node. It's internally depends on the Spark. We will not decide that.
Okay.
Am I clear or confusing?
We'll take it later with some more example.
Yep,
If I
yep,
have
yep.
a conclusion. Yeah, sure. Thank you.
Yeah. Okay. So now application here is it initiate the Spark context, create RDD DAG, and internally when internally it creates stages, which is also responsible. The Spark application is responsible for that. And then, as I said here, each stage is split into tasks. So these are the few responsibility of the application. And one more thing, the task, how the task is created, is based completely based on transformation. And so RDD is having two components. The first is a transformation and second one is an action. Transformation is nothing but creating an RDD from an existing one or from a data source. And action is nothing but we are going to execute that transformation which we have created. Until unless you don't call an action, the exactly we will not able to verify key are the transformation that we have created is correct or incorrect. Okay, so these are some of the responsibility of the Spark application. Okay, and the worker, third is what? Worker. So worker is basically responsible to execute the job with the help of executor and task. So how exactly this happen is I have submit an application. The application is going to initiate a Spark context. Spark context has having cluster manager. Now the cluster manager will interact with the worker, but Spark, as you can see, Spark context is going to interact with the executor, and it will tell which are the jobs you need to execute. So this is the complete architecture of 1.x. Now the only difference between Spark 1.x and 2.x is here we are using Spark context as an entry point, whereas in 2.x we have to use Spark session. The only difference is Spark 2 we need to create Spark session. Rest everything is going to remain same over here. Nothing is changed. Still, we have Spark context, we have cluster manager, we have worker, executor, task, everything remains same. Inside that application, the way we create this application, Spark application, in 1.x we used to create with the Spark context with the help of Spark conf, but here we are going to use Spark session. And how we will create that Spark session is, and sorry, this Spark session is present inside we need to import this package from Spark SQL. PySpark.sql, we need to import Spark session. Then we will use builder object. We are going to use builder object here. Dot. If we want to like we want to execute locally, however we want. These are the other properties. We'll talk about it later. I'm just showing you an example of how we are going to create a Spark session object. App name, whatever you want to give over here. Dot get or create. So this is the basic way to initiate and Spark in Spark 2.0. So basically we are going to use a builder object here to create a Spark session. Rest the entire property and features are same. And the other difference is like is Spark one. If you want to use a SQL property, then we have to define SQL context over here. If we want to use the Hive property, we have to define Hive context over there. But here in Spark 2.0, we all integrated at one place. That is nothing but at Spark. And the best part, which I was talking, I told you to create the account on Databricks Community Edition. Even there, you don't need to do this step. It's already encapsulated over there. You simply whatever the function you want to use, Spark dot create something, you can directly use. This is internally built in Databricks. You don't need to do anything explicitly. You don't need to write this piece of code as well. Okay, so this is the basic difference between Spark 1.x and 2.x. Anyone is having any doubt here? Shashi, we have need to install any package. Which package, Shashi, you're talking about?
Just you mentioned one of the code now. So you have in that particular code you have used some PySpark.SQL.
No, nothing. No explicit package required. This
Okay.
everything is inbuilt. You don't need to install any other package. Okay. So if I talk about the difference, so the basic difference is like in Spark 1.x, we need to for SQL we need to define SQL context. For Hive we need to define the Hive context. But here everything is mixed, merged, and we have only Spark, which is like all sort of thing mixed together at one place. Okay. Second aspect is the 1.x having less function supports, as 2.x having and they have enhanced it and they provide you other n number of features, and it is having a rich set of function and modules which help us in the data processing. So till here clear. Architecture 1.x and 2.x similar. 1.x and 2.x is similar. Only the difference is in application, the way we create the application. Here we need to depend on the Spark context. There we need to create a Spark session. And Spark session is like we will create n number of Spark session. It is not like in application we have only one Spark session. We'll create another Spark session. We can create it. That's not a problem. But it will share the same Spark. Whatever the session will create over here, it will share the same one Spark context. Spark context can be one, but the session can be n. That is only the difference. But there in 1.x we have only one application and one Spark context. But here session can be different. Like I have login from one session and the other user has login from the other session. Same session, both the session can use the same Spark context. It is not like for each session there will be for each session there will be different Spark context. Spark context can be one, but the session can be different. That is the point over here. Am I clear till here now? Or anyone is having doubt?
So I have one question, a little different from basically PySpark is when we are using Spark, when we are using Python language on Spark, right? That is called PySpark, right?
Correct.
Okay.
Correct. That is PySpark. Okay. Just I'll talk about a little bit about the component of Spark, and I think in today's theoretical section, if I'll talk about more, the people will start sleeping over here. Okay. So let's talk about the final point which we have discussed, which we have planned for today's session. So Spark context, basically it is built on 5 components. The first one is Spark core. Second is SQL, Spark Streaming, Spark Graphics, Spark Machine Learning Library. So these are the 5 components of the Spark. Okay. And top of that, most of the places, some of if you do some Google, and they will include Hadoop as well for the storage purpose. Some places they use yarn, mesos, or cluster. Okay, but basic component, if I have to say the basic components, so Spark is having these 5 basic components: Spark Core, Spark SQL, Spark Streaming, Spark Graphics, and Spark Machine Library. Okay, so these are the 5 basic components of the Spark. So Spark Core is nothing but Spark Core is the execution engine for Spark platform. This Spark Core is an execution engine for the Spark. So if I have to draw an arc, sorry. Let me define some diagram over here. I'm not that much good. So this is nothing but my Spark core. On top of that, we have SQL, Spark Streaming, and we will have graphics, and then machine learning library. So all this interacts with Spark core. Okay, and on top of that also, this is going for the storage purpose. That explicitly we need to depend on either HDFS, S3, or whatever one. So this is the complete, these are the components of the Spark. Okay, so Spark SQL is like it will provide you flexibility to work on with SQL. Streaming is like a real-time streaming process data if you want to process it ML is a machine learning library, and graphics is used for the visualization purpose. I have not gone through with I've never gone through with the Spark graphics, how exactly it is. Machine learning and streaming, I'm going through with that. That I don't have much understanding about it as of now. But if you guys will think, we'll have a session on that after 2 3 months when I have some complete understanding about it. So these are the components of the Spark. So basically, Spark SQL is used to submit your queries. If user wants to submit the query in SQL format, they can go for Spark SQL. And here, Spark Course offer you RDD. Here, Spark Course offer you RDD. Internally, whatever the things you are going to do with that, it is built on top of Spark Core. So this is the complete Spark component. Any doubt here?
You mentioned one more thing, which was Jan, and one more thing. So where it comes in this architecture?
What is that? That cluster they can set up anywhere, like this, like this entire execution, either they want to use on yarn or mesos, whatever they want. Let me correct this. Can anyone help me how to erase this? I think this one. This will build on top of it. Let me correct this. Okay. So either they can use yarn or mesos. That cluster they want to decide, or standalone. So this is okay. Fine. So later I'll in this training agenda we'll more discuss about this. But sorry, we are not going to touch anything related to this other things, streaming graphics and machine learning library. Okay.
So this HDFS and S3 are in storage spaces, right?
Yes. Oh, sorry, I missed one thing. It will be like both way, both side arrow. Oh, we don't have any functionality over here. So it will be like both side communication. But here it is one way.
And where does the you have written Spark SQL? Where does the other languages fit in here? As you mentioned, we can use R, Python.
That is the API that's come under Spark core only. The language Sparks, it provides you language. It is not part of the component. That's not a part of the
Okay.
component. Okay. That's offer you. But the component is this. It is a both way. Fine. So I think today's theoretical section is done. If you guys think I should go for, if you have time, I should go and show you how you can initiate the cluster and file in Databricks.
Yeah, sure. At least a little bit.
Sorry, I can you please come again, Siddharth.
I'm saying at least we can have a small session for that. At least we get in touch for that.
Okay, fine. Let's fine. We don't have to do the style database community edition. Okay, go with this one. Already my user ID and password. The signing already. Subham is asking Spark clusters are what? What? I didn't get you, Subham. What's the question? Subham, are you there?
I think Anubhav, I think he is asking question that you mentioned Spark cluster, right? So means what does it mean? Means like is that something like are we doing segmentation kind of thing, or is that related to
See,
data splitting?
cluster is nothing but a collection of your hardware. Here, if I talk about all the driver nodes, worker nodes, storage, everything comes in this cluster. Okay, that's a commodity hardware that you have, and where exactly you want to
Okay.
install executable jobs. Fine. Okay, so once you log into Databricks, this is the UI which you're going to see. In left panel, you can see ki home.
Okay, understood. Thanks.
Okay, yeah. So in the left panel, you can see we have a different options called home, workspace, recent, data, cluster, and jobs and search. Job section you can't do because since it's a free edition, you can't submit your job or you can't schedule your job. You have to license for it, but you can create a cluster. So for running any sort of job or anything over here, the first and most thing required to you over here is to create a cluster. Simple. Just click on this. Okay, I already have a cluster, and one important point about this, if you left your cluster for 2 hours, it is going to terminate. It means that you need to recreate your new cluster, or if same thing, you have to recreate it. But if your system is idle for 2 hours, or if you are not doing anything here for 2 hours, this cluster is going to terminate. Now click on the create cluster, give any name. Station 1 PySpark. Okay, now here is the environment which they are providing. So 6.5 it is the latest one I'm choosing. It is having Scala 2.1.1 and 2.4.5. Less sorry, recent one I'm not. See guys, one more thing important. Don't go as of now for Spark 3.0.0. It's still they have some issue with that. So you might just face some issue. So beta, which is a trusted and verified. So go for any Spark 2.4.5 cluster if you're trying to set up any environment on your system. Okay, so here I'm going with the 6.5 basic version. So let's see what it is going to offer here. So Spark 15 GB memory as a community edition user, your cluster will automatically terminate after an added period of 2 hours. So we'll be getting 15 GB of memory here. You can any Spark configuration, if you want to configure it, you can do any environment variable you want to set it up, you can do it and go over here and do that. But as I suggest, you don't do anything over here, just simple put that name and click on the create cluster. Here we have, see, it's showing you one driver 15.3 GB, and this DB unit is nothing but it's a cluster size, that is a database unit that Databricks offers you. Okay, so now I'm clicking on click to create cluster. So it will take around 30 seconds, 30 to 45 seconds to create a cluster for you.
Anubhav, just a question. just like we are using Databricks, can we use an application of AWS or Azure to use Spark? Is there any app on those cloud platforms?
I am not sure about that. Uh, Cloud platform, I need to see that. I'm not sure if anything in Amazon we have or not. Even in Azure, if you have to use Spark, you need to go with the Databricks only. Azure, I have worked on that, so I have idea about, but Amazon, I'm not sure. I have to see.
Okay.
So as you can see, it's creating. Let's leave it. Now, see here, cluster is the section where you can create a cluster. Data segment is what? Okay, if you have any flat file or something, if you want to import that, click on this add data. See, I will show you PST or somewhere it is having flexibility to do that, but since it's a free edition, you won't get any sort of URL or key to provide to link with the S3. So only option, you have to manual upload a file over here and do the processing whatever you want. So suppose I am creating a sample file name text file. Okay, I'll put name as testing name, and one more thing. I'm just creating some sample data. So I'll show you how we can import. So this is the file which I have created. Okay. Now I need to import this file to our database side. Click on this data, add data, upload a file. You can browse or directly take this and drop it over here. Okay, it will give you a tick mark. It is uploaded properly or not, and it will give you the file location as well, where this file has loaded. So this is the location. I'll show you later where this file is. Now go to any of home. If you create your user ID, so it will appear like this, and you will have your username over here. And if you don't have, because I have created all this notebooks, so it is appearing. If you don't have, just click on it here and create a new notebook. You can create it. Okay, so since I have already, I'm going to use the existing one. Click on anything.
Nubhav, I
I
have one question here. So, means we are creating cluster here, but what's the main purpose behind it? Why we are creating cluster here? Means uh, you can say like a stored procedure means we created one cluster and linked one file, but what's the main purpose behind it and why we are doing it?
cluster. Without cluster, how you're going to do anything? You don't.
So,
Cluster offers you driver, worker, everything, memory to store your data, to process, to execute.
so means what you're saying is means first like we have suppose a bunch of data is there in an Excel file, then you are creating one cluster to import within the like cloud area, and then we are doing some coding and everything for like further like analysis purpose.
I didn't get you.
Correct me
Sorry, I
if
lost
I'm
you. I lost you.
means
Please come again.
means I was saying like means first we created one cluster within that means one file is there within that some 5,000 rows of data is there. So we imported that file via creating one cluster. Then we are writing some code to do like a further analysis.
Okay.
Am I correct or means?
See, these two activities different. You can add your data before cluster, before creating cluster as well. It is not required. If you simply want to upload your data, you can go click here and upload it. But the purpose, if after uploading the data, you want to do some sort of manipulation or some sort of processing you want to do on the data, if any sort of action or any sort of job you're trying to do that, then you need to have a cluster
So
in your
means
hand.
job is again like comes as a like a scheduling like in SAS or other environment.
The
Means we
job
do
is,
automate our code. Means I'm just relating like we do automate our code and just pass all the required information, even the path, and the next day when we come, we just run it or or we just hit one time. So means are we doing the same thing here?
see, job is here, what I'm job is referring here is to perform any activity.
Okay,
Okay, it is
but
not like the optimization also do anything you want to do. Only thing you can't schedule your job. Like I have designed a job which run which I want to run 12 o'clock midnight. That I can't do it over here because
okay,
since it's a free edition, you can't do it.
but I'm I'm sorry, means I'm not able to understand what's the main purpose of the cluster, means, and how it's like a advantage and means how it is helping us.
Okay, so
I think Manohar,
cluster.
cluster is something like if you want to process anything on your machine, so use processors. Similarly, on cloud, you have to initiate a cluster in which this is a compute engine where you will be performing all the processing. So you need a processor or the compute engine to perform any activities on the cloud. So this is where cluster comes into the picture. I think, am I right,
Yeah,
Anubhav?
Yes, yes, right.
okay, that's all my issue. Thank you.
Okay, fine. So that data I have uploaded. Let me show you how we can retrieve. Don't go with the code as of now. Maybe you won't be able to understand, or later I'll discuss about. Just do a thing. Uh, okay, I'm creating a data frame.
Hello.
Yeah.
So the clusters create like parallel jobs for processing.
Sorry, come again.
The clusters create parallel jobs for processing.
Maybe internally it can, but
So it
since
processes in,
if
yeah.
I talk about this, I don't have any huge amount of data. I have only few data. It won't create a
Yes.
parallel job here. Okay, it depends on how your data is split across your node. Now it depends on that. If your data is split across your worker node, it will create a parallel job for it.
Okay.
Okay, let me show you. See this. I'm just showing you an example. Here it created two jobs, Spark jobs. You can see here highlighted. Where is my cursor?
Yes.
Let me show you something. You can see this Spark jobs, two Spark jobs parallelly it create. Okay. Now and sorry, I want to show something where your stages and those. Okay, it executed. That's what it is. It got. Okay, let me see if it is going to create over here now. So here I have created a cluster. Now here you need to drag down and see. I'll create this one, which I have created just now. Spark session. This is Spark. Confirm it. Until unless green signal will not appear, you won't be able to see. Now it's a green signal appearing here. It means your cluster is ready for the execution. Now the simple code I have written, I'm going to execute.
How do you run it here? Control enter.
Yes, control enter, or wait a second.
Hello.
Yes, 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 yes.
Uh,
Just give me a
Yeah.
second. Just
Yeah.
give me
What
a
is the data
second.
types of the data frame?
Here by default we all having. I put it as a string. Okay, I have not do any sort of computation or nothing. Okay, it's simple that I have show you how to upload a job and where exactly the job and how we are going to rate it. It's simple. Later
No,
I'll
no.
discuss about how you're good.
No, in the top cell. Can you?
Anubhav, again, I have one question here. Like earlier, you have mentioned when we create cluster, it always stay for 2 hours. Means
Correct.
we do imported. Means we created cluster and imported a file here and
Hmm.
written some code and did some further like manipulation or cleansing. And we saved code, but like cluster is gone. Means next day when we opening it, cluster is
Hmm.
gone. Means data is gone. Correct? Or data is already uploaded.
This data remains even your cluster gone or it doesn't. I'll show you where this data is.
Okay, great. Thank you
uh,
for the
Cluster,
clarification.
See here,
Cluster is just
when
execute the job, right?
cluster is only compute the job, even
Yes.
though after your cluster is disappear, you have your data in your cloud platform.
Yeah.
I'll show you, but whatever I discussed till now, I want to show you how. See, somewhere I have see so this job stages task partition. See here, job is segregated into stages, and one stage having one task over here. Here, since our data is very less, only 3 records we have, that's what it will not segregate into multiple tasks or something. But if you have data size is huge, it will split, and you will be able to see over here in list. It will show you stages, and then we have jobs. Here we have one stage, one job, but it will show you one stage is having 10 jobs as well. Okay, so this is how
Hello.
internally it creates and it execute.
So stages and jobs, how are different?
See, once you submit, this particular is nothing but this is a job I have submit. When you called any action or something, this is a job. Suppose any command you submit, it refer to as a job. As of now, you understand like that. Then
Yeah.
that job will see how much the data size it is, and where in how many worker node it's splitted, or in how many partitions the data is stored. So here we have very less data. I cannot demonstrate over here as of now, but later onwards, I'll show you something which will give me one stage, and if one stage is having n number of jobs as well. That
Okay.
leave it as of now. Later we'll talk about it. But the today purpose is simply to show you how we can upload this data and how we can retrieve it. We have used data frame. I have shown you. No, I told you here. We don't need to perform all this sort of activities as well. In Databricks is already by default. So I have not done anything. I have simply used Spark. That's it. And these are the subsequent properties to read a file or something. And if you want that key data type, if you'll see, it is showing you over here key name as a string and age as a string. If you want
Yes.
to this data type should be integer, then we need to enable an option called infer schema. I'll talk about it later, not today. That is separate section when I'll talk about that data frames and Spark SQL. There I'll explain you each and everything. Now, if I want to see where this data resides, okay, you want to see where this data is. Sorry, go into data, add data. As you can see, we have DBFS, that is Databricks file system over here. In DBFS, go to file store tables, because internally it created tables for it. Something called texting.txt. This is our file, right? So all your file will remain over here. Even if your cluster is disable, you switched off your system, anything you want to do, but your data will remain over here. It will not disappear. Okay, am I clear?
Yes. So one thing means by default Spark take a string as a data type, right? If we don't provide
By
any
default,
integer.
everything it will deal as a
Yeah.
string. If you want, I'll show you something. Like if you want, no, I don't want that data to be string. I want to be as it is what it has. Like if it is a string, it should appear as a string. If it's an integer, it would appear as an integer. I'll show you.
For inference schema also you provide some other file in which we have mapping.
No. Here only if I do nothing but dot option, maybe it will throw an error in terms of spelling. I always do. Let's see, it throws an error or it run. See, it changed to
Okay.
by default double,
Hmm. Okay,
right?
everything
But that too also it is not correct. It is an integer.
yes.
Then we need to go for our own custom schema. That's a problem with the infer schema. If it
Okay.
is
So
an integer, it will be
inference schema is the one which takes the default data types of every module
aha.
string and
It will
integer and all.
see the data inside each column and it will infer accordingly. But it is having a drawback as well. The
Mm-hmm.
first drawback you have already seen. My data is integer, but it differentiate as a double.
Yes. Got it. Thank you.
Okay. And one more issue it has, it will create, if you notice that earlier it is having two jobs here. If you
Mhm.
remember
Yes.
earlier it shows two Spark jobs. Now it create
Mhm.
three because we have infer it, so it will create an extra job to verify the data inside each column. So that is a disadvantage. The
Yes.
performance will reduce over here. That's why we used to go with our own custom schema through struct type and struct field. We used to create our own custom schema. In that, we'll define that this one is an integer. It will create an integer. Later, I'll talk about it, how exactly it is going to. In
Okay.
further
So,
session, I'll explain about that.
Anubhav, here we are using Python API, right?
Yes,
Okay. We can use other
and
APIs
one
as well.
more thing. Other APIs as well you can use, but for the reading data through Scala also you can do that. Through Java also you can do that. It's up to you. I can read this data in form of RDD as well, but I have not read. I just simply want to show you some of the other stuff. That's what I have gone with the data frame. Okay. So anything else, guys? Any questions?
So this is an RDD, right? While we are reading the data.
No. This is data frame. We can read an RDD by two ways. The first one is a text file method we use to create an RDD. Another one is a parallelize method. If you are
Yes.
reading directly, it will create a data frame.
Oh, okay. Yeah.
Okay.
Means by default, means data frames is also like at the backend they are RDD, right?
Internally, when the execution starts, so it will internally execute in the form of RDD. But here, if you
Mm-hmm.
talk, let me execute one more thing. It
Anubhav,
shows
what is RTD?
type DF, that is resilient distributed data set. I'll talk about in next session about that in more brief. See, I have simply not done anything DF and I have it put into what it shows. It is a data frame. You can see here.
Yes.
It shows it is a data frame, and also here it defines data frame have name as a string, age a double data type it shows. Okay.
Hello.
Yes.
Yeah, so for reading JSON files,
Hmm.
so then also it will create this table.
Yes, for everything. You don't have to do anything. Just simple here you have to use JSON. That's it.
Hello.
Yeah.
Yeah, so it can like store as key values in JSON instead of creating tables.
So internally, everything it will create in the form of table. Even though if your data is a JSON, internally it will create as a table. But explicitly, when you're trying to retrieve the data, it will appear as a JSON.
Okay.
Yeah, I might have some JSON file as well. Let me see. Let me show you something. Oh, txt. Okay, I think I have deleted that. We can do that, but still, it will internally treat it as a JSON only. Oh, sorry, table only in database.
Okay.
Okay. So I think we are done for today's session. So tomorrow's session, tomorrow not next Saturday, I'll talk about these 2-3 concepts. And next Saturday's and Sunday session.